Okay, guys, today we are going to be looking at converting points from polar points to rectangular points. So last time we learned how to plot and name polar points, and today we'll start converting. So what you guys will need today is your unit circle, and you might want the notes from last time as well. So just like before, we'll start with stuff we know and see how that can help us figure out something new. So our focus today is from polar, so r theta, to rectangular, x, y. So we can convert back and forth, kind of like when we have degree measures and we convert it to radians. It's a similar idea. It's a different way of naming the same information. In order to do this, though, we're going to want to know some different equations that relate these variables to each other. So r theta and x and y. So if I have a point in polar out here, it's r comma theta. R is the distance to the pole, and theta is the angle. Now, if that same point is written as a coordinate in x, y in rectangular, it's the vertical and horizontal distance. So that just created a right triangle that we can use to figure out some equations. So thinking back to our last couple of units here, if I am trying to relate these variables to each other, let's just think about what we know about the cosine of theta for that right triangle. Now from SOHCAHTOA, cosine is adjacent over hypotenuse, in this case, x over r. Now if I can solve that equation for x, then I have a way to convert between the x coordinate and our polar coordinate. Just like in trig identities, if we have an equation that's equal to each other, we can use them interchangeably. So to solve that for solve that for x, I'm going to get rid of the division by r by multiplying by r on both sides. So now my equation is r cosine theta equals x. Let's just hang on to that for a moment. I also know that sine is opposite over hypotenuse, which is y over r for this particular triangle. Again, I'll solve that for y by multiplying by r on both sides to undo that division, leaving me with r sine theta equals y. Now, this might not seem very useful yet. Let's look at some actual examples here. So if I want to convert this polar point to rectangular, in polar, this is r and theta. I know from our work above that x, so the x coordinate that I want in rectangular, x and y, I want an x coordinate, that equals r times the cosine of theta. Well, I have r and I have theta, so let's plug those in. R is 6 times cosine of 120 degrees. So here you'll need your unit circle because I'm going to evaluate. I have the 6 still times cosine of 120 from my unit circle is negative 1/2. 6 times negative 1/2 is negative 3. So now I have my x coordinate. I can do the same thing with y. Y equals r sine theta, plugging in 6 times sine of 120, so r and theta. 6 times sine of 120 from the unit circle is root 3 over 2. So when I multiply these, 6 times root 3 is 6 root 3. 1 times 2 is just 2. I can simplify 6 divided by 2 to give me 3 root 3. So my final answer is a coordinate point. X is negative 3. Y is 3 root 3. So if I could plot both of these and lay them on each other, so plot this point in polar and plot this point in rectangular, put them on top of each other, they would be in the same spot. Okay, that's what we're doing here, is just converting the same point to a different format. Let's look at one more example together. So point B here, same idea. This is r and theta. So if I want the x coordinate, I'll do negative 4 times cosine of 135. So I'm plugging in, x equals r cosine theta. Again, plugging in r and theta. So cosine of 135 from the unit circle is negative root 2 over 2. So you can think of this like negative 4 over 1. And negative times a negative becomes positive 4 root 2 over 1 times 2, which is 2. Simplify your fraction, 2 root 2. Same thing with y. Y equals r sine theta. Plug in r and theta, negative 4 sine of 135. So I have negative 4 times positive root 2 over 2 from the unit circle, which becomes negative times a positive, negative 4 root 2 over 2, which simplifies to negative 2 root 2. My final answer is the coordinate put together, x and y. And then I am done. I want you guys to try problem C on your own. So pause the video, try problem C, and then when you play back, the answer will be up. So here's my answer for part C. This was a radian measure, but again, we evaluate the same way. So I have my final coordinates as 2 root 3, comma 2. You can see my work there as well. And then really quick, the last one here looks like it might be tricky because of that 13 pi over 3. But if we start to plug into our formula, so x equals r cosine theta, we have x equals 0 times cosine of 13 pi over 3. It doesn't matter what cosine of 13 pi over 3 is because we're multiplying it by 0. So 0 times anything, still 0. Same thing with y. So I have r sine theta. Y equals 0 times sine of 13 pi over 3. Same idea, 0 times anything, still 0. So this point in rectangular is on the origin, and in polar, it would be on the pole at the center because we're moving 0 units